All right, how's it going, guys? So it's 9:05 or 1:05, excuse me. Give everyone a few minutes to just kind of get in with this being the first day. Um, some people, if you're on here and you can't use the chat box, we've kind of discovered this week that you can't use the chat box if you're on your school account, because technically YouTube doesn't allow kids to use the chat box, and we kind of understand that. So with that being said, if you can't see the chat box, you may want to log out and log into your personal account. Let me just do a quick audio and visual check. Can everyone see and hear? Just give me a smiley face or a thumbs up or whatever you want to do in the chat box. All right, Colton's good. Morgan's good. So Colton and Carter are good. Katie's good. Ian's good. And we're going to assume Tim, Alex, and Ben may show up at a later time. So, first, let's go to. Let me adjust the camera a little bit. If you guys hear anything crazy happening, dogs barking, kids screaming, just know it's just normal around here. So, I don't know. Obviously, I haven't seen you guys in a very long time, so I didn't know what the attitude was towards number 22 homework optimization. All right, thanks for showing up, Timmy. But I didn't know what the attitude was, like if we were just like totally lost, if it was like, hey, this kind of made some sense or whatever. I can kind of put this up here, but let me get yours. Let me get your guys' thoughts on number 22 homework, that optimization, the first one. And we don't have to like be totally negative, so you don't have to be like, I didn't get any problem or anything like that. Okay, cool, Katie. Okay, so obviously this is a different setup than what we normally have. Okay, cool, you. Um, I don't know if it would be best for me to like just kind of work through this problem or just post the one that I completed online, so you can go back and just look at it in that. Or I mean, obviously can flip through it and talk through a few. But understand that with this being on a on like a video lecture, it's going to take a little bit of time. So if we went through every single problem and did the notes for 23, it's going to take us a little bit of time. I would say greater than 2 hours. But let's not get discouraged by the time, just because literally we don't see each other at all, and I've only have us meet like a couple times a week. So I appreciate your patience with the time, because these are probably going to be pretty lengthy lectures in terms of time. Yeah, go ahead, Katie. That's fine. Let's ask specific ones like, hey, number 1 or number 2, number 3, whatever it may be. Easy. sorry. So let's address Katie's. Sorry, my dog's barking at birds. So let's address Katie's question. How do you know if you're finding the min or max? Does the general step by step we do find min or max? So again, that's when we came down to the whole underlining what we're looking for. So find two numbers whose sum is 10 for which the sum of the squares is a minimum. So when you're looking at like a primary and then secondary and then plugging the secondary back in, when you're taking the derivative, keep in mind, remember those sign charts we made? We were able to find maximum and minimums on those sign charts. So that's what we were. So you can actually find both a max and a min by taking the derivative of the primary function once you plug the secondary in. Number 2, on numbers such as 7 and 10, what do you do if you have more than 2 variables? Okay, yeah, we'll address that. So let's look at, let's go to number 7 on that homework. So with number 7, if you're thinking about this, and Katie brings up a good point, what do we do if we have more than 2 variables? So technically we have the volume for the primary is technically length times width times height. But with this right here being a square, and that's the point of this one, with this being a square here, we can say the width and the height is y squared. Does that make sense on number 7, Katie? On how we can make the width and the height y squared, or y times y? Okay. And then we said number 10. And I'm going to assume for number 10, you're referencing, you're talking about the r, and we can just make the rx for the circle, is what I'm assuming you're, because r is just, it's an unknown, so we can, the radius is unknown, so we can just make it an x there as well. Right. Okay. Yeah. Okay. Good question. So how do we know that this is the secondary equation? So remember, the secondary equation is going to come from something that's restricting it over here, something that's restricting everything. And what's restricting this, or what's like has to be true, is that the total outside perimeter has to be 10 feet. So the total perimeter around the whole thing has to be 10 feet. So there we can say, based on the perimeter of the rectangle, 2x and 2x plus 2y allows me that perimeter. And then, of course, the perimeter of the circle would represent the circumference of a circle. And you need to know that the circumference of a circle would just be pi r, or pi x in this case. So this perimeter plus the semicircle's perimeter would be equal to 10. So how did I get 2xy for the primary for the rectangle? If you broke this down into two rectangles, this one big one into two, so I have xy and I have xy. So I have two xy's. Two of these rectangles, x times y. So I just say 2xy. All right. And give me like a thumbs up or a smiley face if we're cool. I'm gonna go look at or hold on. Let me I'll type that in, or I'll answer. So you don't have to break it down. I just saw it easier in my eyes as like a window, like opening out like that. So you wouldn't technically speaking, you wouldn't have to break it down. So you could still solve it using the primary. That's just probably my personal preference. All right. Now let's go to 13. I'm not seeing any other questions come through. And again, I'll send you this so we can so everyone can have it. Okay. So 13, you can actually be solved two different ways, but there is a much easier way if you know similar triangles. So if you don't know similar triangles, you just basically we're finding the distance of basically the hypotenuses of from town 1 to S and from S to town 2. We're just basically finding those hypotenuses. But if you know similar triangles, you can just set up a proportion here in order to see obviously where X would be best in order for them to be equal. So if you said X over 1, well, that is equal. This X right here, let me take this cap off. This X right here over this 1, which is what we have. It's what it's given us for this triangle. X over 1 is equal to this triangle's this vertical distance, this is a total of 4. So 4 minus X, which we don't know what X is, and then over this distance, which is 4. So we have similar triangles. So if you want to keep them similar and equal, then you just set them equal to each other, the parts that you have that are equal. And then just from there, you just cross multiply, and then you find X is 4/5. And that just kind of goes back to some of these you can see a different way. I think there was one that we did on the notes when we were in class, like where we said, well, only thing you got to do is just split the. I think it was Katie that said, don't we just got to split the number in half? So some ways you're going to see it a little bit more logically, opposed to algebraically, and here would be algebraically. So it would be taking our distances from town 1. Okay, so I don't know the distance right here of from town 1 to S. So, but I put those together, and then I take the derivative of that, and then I solve for X, which down here I get the same answer as 4/5 X, or 4/5 mile. And I'll send this out to you and you can kind of see all the work I did. But in order for you to determine the distance, you use Pythagorean theorem there. A squared plus b squared equals c squared, where you know that that's 1 squared, which is 1, plus x squared equals c squared. And then just do the square root of both sides to get c by itself. So the distance from this right here is the square root of x squared plus 1 squared, or 1. And then we just add that to down to this one, which is 4 squared plus that 4 minus x here squared, which is a binomial times a binomial, which takes you to a trinomial. And then it gives us this right here. And then we just start basically deriving from there. Since we have all the same variable. Are you following any of that, Colton? Okay. All right. If you don't like optimization problems, I hate to tell you this, but we're about to go right back into them from more of a financial side. I saw that on Twitter, Timmy, that where they said they're trying to, where they said they're going to. I saw where like the AP president or whatever he was said something on Twitter about, they're looking at ways to possibly move it online. I don't see how possible, but I'm not them. Okay. Don't freak out about what specifically, Morgan? Oh. Well, I have an inside too, Morgan, and they told me to tell everybody to freak out about it. We all have an inside, right? Okay. So I'm going to assume that everyone has a packet. Since this is a live recording to which other people have access to, I can't, I don't want to comment too much. That's right, Morgan, 4 handshakes away. I'd rather not comment on the AP test being online. So just because who knows who's watching this? I'm not sure. So give me a smiley face if you have this right here, the classwork one. Just shoot an emoji like the smiley face or a thumbs up, whatever, that you have the 23 economic optimization classwork. Smiley face. Thank you. Good, Timmy. Good. Caitlin, did you go by the school and get one? Good, Ian. Good, Morgan. Nice. Very good. Didn't know people had printers at their home. Colton and Carter, you guys still with us, or are you guys like, I'm not sure what you could be doing. All right, cool. So here we go. Number 23, Economical optimization. I can't talk today. Economical optimization, that's spelled wrong. Problems are approached exactly like those in the last section. Typically, we wish to either minimize costs or maximize profit, or given a cost as a constraint, we may wish to maximize other factors such as size or efficiency. In economical optimization problems, we are still interested in maximizing or minimizing some measurement given a set of constraints. So, instance, suppose you wish to purchase a new car. You want a car with the following features: air conditioning, power windows, cruise control, sunroof, a navigation system, leather seats, anti-lock brakes, and keyless entry. You have saved $25,000, but may be able to come up slightly more money, although you are reluctant to. You also realize that you might not be able to get all the features with that amount of money. There are several approaches that people usually take. Approach one: spend $25,000 and get as many features as possible. We are maximizing the features given the constraint of spending no more than $25,000. Approach two: find a car with the features and spend as little as possible, even if it's over $25,000. We are minimizing the price given the constraints of getting all the features. So this is an optimization problem. Either you maximize the features or minimize the price. Sadly, you cannot have both: a lot of features and a cheap price. So first problem. And we're going to follow these just the way we worked the last ones. A trucking company has determined that the cost per hour to operate a single truck is given by C of S, this function here, where S is the speed that the truck travels. At what speed is the cost per hour a minimum? What is the hourly cost to operate the truck at that speed? Assuming that the truck can travel from 0 to 75 miles per hour, what is the range of hourly cost to operate the truck? Okay, so the first thing we want to do, we want to, at what speed, if S represents speed, at what speed is the cost per hour a minimum? So in order to determine that, we need to derive this right here. Okay, so C of S is equal to 0.1 S squared minus 10S plus 450. Since I have the same variable here and I'm wanting to find the maximum, or the minimum of this, and since there's just one variable, I can simply derive that. Set it equal to 0 and derive. So that would be 0.1 times 2 would be 0.2S minus 10. Okay. Then I add 10 to both sides and get 0.2S. Divide both sides by 0.2. And I find S to be 50. And of course, that's going to represent miles per hour. That's one answer. Then it asks, what is the hourly cost to operate the truck at that speed? So if S represents speed, and this is the function that determines the cost per hour, just plug that back in. So C of 50 is equal to, and if you have a calculator, if you brought that home, I'd have that out. And C of 50 would be here 200. That's just plugging 50 back into these S's. And you would get 200. So at what speed is the cost? We've done that one. What is the hourly cost to operate the truck at that speed? C of 50. Assuming that the truck can travel from 0 to 75, what is the range of hourly cost to operate the truck? Okay. So we just need to basically find the endpoints 0 and 75. So what is C of 0 equal to? And what is C of 75 equal to? Someone type into the box what C of 0 would be. That one's pretty easy. What would C of 0 be? Good, Ian. 450. Good, Colton. Okay, and then what is C of 75 would be 262.50. So someone type in my range. I don't care who it is. Type in range for what this would be. What would my range be of hourly cost to operate the truck? Alrighty then. So my range of the hourly cost to operate the truck, well, at 0 it's 450, and at 75 it's 262. But don't forget, when you're traveling at 50 miles per hour, that it's at 200. So my range, that's the minimum. So I would say my range would be from 200 to 450. Sorry about that. So we would say it costs anywhere from $200 to $450 hourly to operate the truck. And some of you may be saying, well, why does it still cost money when they're not driving? And of course, you would understand the maintenance, gas, the initial amount of gas to go into the truck. So even if it's not going, there's still costs involved. Okay. Thumbs up, smiley face, something if we're good on that. Thank you, Morgan. Thank you, Ian. Okay. There's 3 of you. There we go. Okay. Timmy, you good? Are you still with us? Or are you out there? I don't know what you're doing. Okay. Number 2. All right, cool. Number 2, a nursery wants to add 1,000 square feet rectangular area to its greenhouse to sell seedlings. For aesthetic reasons, the owner has decided to border the area on 3 sides by cedar siding at a cost of $10 per foot, as shown to the figure to the right. The remaining side of the wall will be a brick mosaic that costs $25 per foot. What should be the dimensions of the sides so that the cost of the project will be minimized? What is the cost? And complete the chart. Okay. So here's what we know. We know that there's going to be 1,000 square foot of area in this over here. And we're going with cedar on these 3 sides and a brick mosaic on the front. So what we're trying to figure out is how can we minimize the cost of the project but still meet these standards and these restrictions or these constraints for this nursery. All right. So let's jump down here to width. I find it easier to do the chart first, just because I think you start seeing the picture of what's happening here. So if the width is 10, so if the width is 10 feet, then my length would have to be, well, what 1,000 divided by 10 would be 100. Or another way to think, what times 10 will give me 1,000, because area is length times width. So if my width is 10 and my length is 1,000, okay, just do some quick math in our head here. So what is my cedar cost? Okay, what would be my cedar cost? Well, if length is 1,000, right? 1,000 here, 1,000, or excuse me, not 1,000. I'm sorry, 100, not 1,000. My bad. Surprised one of you didn't correct me. So 100, not 1,000. My bad. So if I have 100 feet here and 100 feet here, that's $1,000 for this. 100 times the $10 per foot is 1,000, 1,000, and then back here, the width would be 10 of that, so 100. So that would take my cost to $2,100. Again, 100 times 10 would be the 1,000. That's my area. So it would look like this. I'd have 100 feet here, 100 feet here, 10 feet back here. 100 times the $10 would be 1,000. This 100 times the 10 feet is 1,000. And this 10 times 10 feet is 100. So 1,000, 1,000, and 100 is 2,100. So then that would make this up here 10. So that 10 feet, because the width is 10 feet in order for it to be 1,000 square feet. So 10 times 25 would be $250. So then that would take my total cost to $2,350. All right, what if it was the opposite way? What if the width was 100 feet? That would make our length 10 feet. So width is 100 now. I can kind of mark all that out. I'm just trying to give you a visual of what's happening. So what if our width is 100? That would make our length 10. So 100 times the $10 is 1,000. This 10 times the 10 is 100. This 10 over here, this 10 times the 10 is 100 if my length is 10. So 100, 100, 1,000 would take me to 1,200. That takes care of those 3 sides. And then the last side, the width is 100 now. So that would be 2,500. Take me to a total of 3,700. What if the width was 1,000? So if the width was 1,000, that would make the length 1 foot. 1,000 times 1 would be the 1,000 square feet. So my cedar cost would be 10 times 1,000, because the width would be 1,000. 1,000 times 10 is 10,000. And then our length here is just 1 foot. So that's 10 and 10. 10 plus 10 is 20, plus that 10,000 is 10,020. And then again, my width is 25 feet. So 25 times the 1,000 width would be 25,000. So that would put the project at 35,020, which is unrealistic. So now from here, we can kind of create what we're dealing with here. Our width is X, our length is Y. Our cedar cost, well, for our X's, our X, for one of the X, we're always going to multiply this X times 10. So I can say 10X. I'm going to write this here. 10X, that would represent this. And then plus this 10Y and that 10Y. So plus 20Y. Another way you could kind of see it would look like this: 10 times the quantity of X plus 2Y. Again, you're multiplying one of the widths times 10, and you're multiplying two of the Y's times 10. So that's another way you could kind of see that. All right, and then the mosaic cost, that's pretty simple. Whatever X is, whatever the width is, just multiply it times 25. And then my total cost would just be these two combined, these two numbers combined. So that would be 35X plus 20Y. So that gives me my primary. If I want to find the primary cost of this, I gotta say 35X plus 20Y. Now here's my question to you. Can I proceed forward and take the derivative of this? Just shoot yes or no in the chat box. Can I proceed forward from here and take the derivative? Very good, Morgan. I cannot, because I have two variables. Notice this one up here. I went ahead and took the derivative because it was only one variable. So those of you that are not really understanding this concept, we're taking what the primary function is of the situation, and we're taking the derivative of it. But if it has two variables, as this one does, we need to find a secondary equation. And how you come up with the secondary equation is it's normally a restraint, something that this represents the function, but something else represents the function as well. What else would represent the function? Someone type, yeah, there you go, Alex. Alex is already ahead of me. So just type in our secondary equation, x times y equals 1,000. Alex comes out of nowhere and just starts answering questions. My guy. All right. So then we solve for y, and that would be y equals 1,000 over x. So our total cost is equal to 35x plus 20 times 1,000, which would be 20,000 over x. So then now we can derive this. Same variable, let's derive. 0 equals the derivative of 35x is 35. The derivative of this, think about if we move that up, it'd be 20,000 to the x to the negative 1. If we flip that up, again, you can do quotient rule here, or just think about if you flip that up and that was 20,000 x to the negative 1 power. That would flip that to negative, and then x to the negative 2. So then you would just write negative 20,000 over x squared. Or you can do low-d high, high-d low over low-low. Either way works. So minus 20,000 over x squared. If I subtract 35 on both sides and then divide by negative, I just get 35 is equal to 20,000 over x squared. I then multiply both sides by x squared. I get 35x squared is equal to 20,000. Divide both sides by 35 and then take the square root of that. And that's where we can use a calculator to find that. And we're going to get x to equal 23.905. So that is going to represent our width. So my width is 23.905. My length then, if I plug x into that right there, that x is at 1,000 over 23.905, I'll get my length as 41.833. And these are all feet. And then it says, what is the cost? So my cost, and that's just plugging these two numbers back into the x here and back into the y. The y would be my length. The width would be my x. And my cost would be $1,673.92. Okay. Questions or thumbs up? Let me know. Morgan, do you have the packet? I'm sending I sent home with you a take-home test for 23. I don't have mine like with me like right now. I can look on here. Yeah, look on that and then see if it has you to fill out the table on that. And again, just to kind of follow up with something like that. Sorry, I'm shaking the table. My bad, guys. To follow up with that, so we're really fighting for understanding here more than we are. Your grade will take care of itself. If you're here every time in the live session, your grade will take care of itself in that terms. And in terms of, what's going to happen from here is just make sure when we come back to school on April 14th, you have everything, all the notes and all the homework and the take-home tests done. There's a lot of tests and stuff in there, but again, I want you to have that understanding. We'll fight those beasts when we get there, and if we don't come back on April 14th, which obviously I don't know what's going to happen from this point, but if we don't, then we'll make arrangements to do something else in terms of what happens. But let's go more on. The only thing I'm giving you is this take-home test, so just knock that out. And then just the notes and homework. And then when we get back together, that's when we kind of develop a plan going forward, if we do get back together. All right, let's go to the next page. And hey, you're completely fine to rip this apart. And this one's a fun problem here, real estate. Some of you guys probably should go into real estate. Okay, so a real estate company owns 100 apartments in Chicago. At $2,100 per month, each apartment can be rented. However, for each $75 increase in rent, there will be 2 additional vacancies. How much should the real estate company charge for rent to maximize its revenues? Complete this chart. Okay, so again, guys, I like to start with the table because I think the table kind of helps you see the problem, in my opinion. So let's start with rent. All right. So if there are no increases in rent, no $75 increases, then my rent would still be $2,100. And then again, there's 100 apartments. So if there's no increases, I would still have 100 apartments rented. And then obviously from there, I would just multiply these two and get a total amount of $210,000 as my revenue. That's what I'm making, charging $2,100 rent with 100 apartments rented. But let's say I increase rent one time by the $75. So that now means that rent is $2,175. But every time we increase rent $75, there will be 2 additional vacancies. So 2 people move out, basically. So now I have 98 apartments rented. When I multiply those two, I get 213,150. We had 75, so now there's 2 increases, so 150 from our original amount, just 75 more to this. If we do 2 $75 increases, I'm now at 2250, but I've increased it twice, so I have to subtract 4 from the 100 or 2 from the previous, 96, and I'm at 216. Still making money, my people. If I do 3 $75 increases, I'm now at 23.25. And I now have 94 apartments rented for a total amount of $218,550. If I have 4 apartments, if I increased it 4 times, I'm now at 2,400, and I'm at 92 apartments rented, and my total revenue $220,800. Okay. If I have 50 increases, that's $5,850 for rent. And if I'm losing 2 people every time the rent goes up $75, that would leave me with 0 apartments rented with a revenue of $0. So now we can create like a formula from this. How are we getting this number? Okay. So we were really just taking the original amount, 2,100, and adding it to 75 times x. So 2,100 plus 75x, x being the number of increases. So 21 plus 75 times 2 is 150. 150 and 2,100 would be the 2,250. All right. Here, how are we getting this column? We're getting this column by just subtracting from 100, subtracting x from 100, but it would double each time. So 100 minus 2x. So again, if there was 1 increase, 100 minus 2 times 1 is 2, 98. 100 minus 2 times 2, which is 4, that'd be 96. And then again, if you notice, we're just multiplying those the whole time. So in order to find the revenue costs, we're just going to say 2,100 plus 75x times 100 minus 2x. And we're waiting on you, Carter, to multiply that out. So R, my revenue, is equal to 2,100 plus 75x times 100 minus 2x. So if you were to multiply that out, you get 210,000. I know we need them. 210,000 plus 3,300x minus 150x squared. Hey, you were close though. Not bad. Not too bad. All right. Then from there, oh, sorry. We have, yeah, I respect him. He's still a wizard. Now from here, just one variable. So set it equal to 0 and solve it out. So that would be 3,300, taking the derivative, minus 300x. From there, you should see that x, once you add 300 and divide, 300 goes into 3,300 11 times. All right. So my rent, okay, So what we're looking at here is that we need to multiply x. So put x back, put 11 back in there, or just put it right here. And our rent, once you put it back in, we would need to see that the rent cost 2,925. Now, quick question for the chat box: how many apartments would I have rented at that cost? What's my number of apartments I've rented? Very good, Alex. 78. Remember, this doubles, so just type that in there. 2 times, good, Timmy. 2 times 11 is 22. Subtract that from 100. And then my total revenue, or excuse me, not my total, but my max revenue. If I use this right here and I punch 11 in there, I should get 228,150. What do y'all think? Chicago, $2,925 for rent. I'm sure if you went to another tab and just type in apartments for rent in Chicago, I'm sure you're going to see some pretty pricey ones. Can someone just type in the chat box, like, what would be like a not necessarily rent, not money, but what would play a factor in this? What would play a factor in someone renting a apartment from here? If money wasn't an issue, what might play a factor? Yeah, of course. Okay, yeah, neighborhood for sure, right? Uh, and I'm not necessarily saying do they, change your light bulbs and stuff like that. Yeah, how good's are the school proximity to my everyday obligations? Yeah, so there's a lot of factors like that. But think about the people who own this company. What they're not living there, but they're, and they know that it's easy to rent these for $2,925 a month. But what should they be afraid of? Loud neighbors, okay? Yeah, yeah, right. Raising rent for sure. Um, but tell me this: how much? What percentage of the apartment complex is not occupied right now? At $2,925. What percentage of the apartment complex um, is not being occupied? Yeah, 22%. So I think that plays a large factor. 22% of apartments are not rented. So you may say, well, what kind of why is that a factor? If you think about, if this was like a yeah, exactly, Morgan. You wouldn't want to be somewhere, and 22% is not bad. That's not bad. But if you think about, if this was a 10-floor apartment complex, if it was 10 floors, 10 floors up, and each floor had 10 apartments in it, so basically 2 of them would be empty. And people would normally, just from my experience, it's just like with friends and stuff, they don't like to be somewhere where there's not a lot of apartments that are vacant, because then you're scratching your head saying, well, why are people, Why are people not here? So just kind of another factor. But I agree with you all. There's tons of, environmental factors out there that can impact it as well. All right, moving on to number 4. A closed box with a square base is to have a volume of 1,800 inches cubed. The material for the top and bottom of the box, the shaded section in the figure, costs 30 cents per square inch, while the material for the sides costs 10 cents per square inch. Find the minimum cost of the box. Okay, so this is like your classic optimization. We're looking for minimum. So that's how we know it's optimization. So I'm going to have a primary here. A primary equation. Okay. And my primary equation is going to deal with the cost, because that's what I'm looking at here. I'm trying to find the total cost of this box. So in finding the total cost of the box, I need to know a few things. So the top and the bottom. So let's first look at the top and bottom. Top and bottom. So the top and bottom costs 30 cents per square inch. All right. So 30 cents as a decimal would be 0.3. And now I just need to multiply that by what's represented over there. So if I have in the problem, it's saying this x and that x, right? So this represents the area, x times x, which is x squared. But I have two of those. I have the bottom and I have the top. So I would say 0.3 times 2x squared. Because I have this x times that x is x squared, the area for the bottom. And the same thing for the top. This x times that x, which is x times x, which is x squared. So I have 2x squared. That's part of my cost. And then I add that to my side cost. My side cost is 10 cents. So that's 0.1 as a decimal. And then I need to multiply it times the sides. I have 1, 2, 3, 4 sides. And that's a y. So I would say x times y gives me this side. Another x times y gives me another side. X times y gives me the third and the fourth as well. So I would say 4xy. So then I can kind of straighten that out and say C is equal to 0.6x squared plus 0.4xy. So can't simplify any further, but I have two variables. So I have to come over here and create a secondary equation. Now here's what I'm going to tell you. You're going to find your secondary equation somewhere up here at the top or somewhere in the problem. And here's what it's given us. A closed box with a square base is to have a volume of 1,800 inches cubed. So we know that volume is length times width times height. Very good, Timmy. So we would say x squared times y equals 1,800. So multiplication, right? Because this times this times this. So x squared and then times y equals 1,800. And then we get y is equal to 1800 over x squared. So now I plug that back in. Over here, c equals 0.6x squared plus 0.4x times 1800 over x squared. Now let's go ahead and multiply that out actually. When I do that, I get c is equal to 0.6x squared. The one of those x 0.4 times 1800 would be 720. Sorry about that. Had to disappear for a second. So plus 720 over that's 720 over x. Sorry. So plus 720 because this x and that x would cancel. Yeah, let me get done with this problem, Timmy, and then we'll take a break. So then from there, we derive this now. So I set that equal to 0, derive, and get 1.2x. And again, same thing. If that was x to the negative 1, it would just change this to negative 720 over x squared. So then I get 1.2. I move this over. 1.2x is equal to 720 over x squared. I then multiply both sides by x squared. 1.2x cubed now equals 720. Divide both sides by 1.2. That actually comes out to be a nice clean number, 600. And then I do the cube root of both sides. So x is equal to the cube root of 600. So based on that, if I plug that there, that's going to give me my height. All right. So I know my base is, if you use a calculator to do this cube root of 600, I know my base is equal to 8.434. My height, if I plug that into that x squared, square the cube root of 600, and put it under 1800, I should get a height of 25.303 inches, and then inches. And then if I plug these numbers back into my cost factor right here, I should get a cost of 128.05. All right, let's do a quick like 5-minute bathroom break. So just come back here at like 2:22. I'll keep the stream up and everything. If you have questions, let me know right now about this. But if you need to use the restroom, go real quick. So like 122, or excuse me, not 122, 222. All right, give me a smiley face if you can hear and see everything good. Just getting going again. Okay, so what I just typed in the chat box, there's a if you're looking like if you're watching on your phone or I don't know, I would tell you that your best preference is to watch would be to watch on a laptop that's hardwire into it, like your Ethernet into your internet box with Ethernet cord, because that'll kind of keep your live stream going pretty well. That's what I have mine through, and I mean I don't know if it looks the best or what, but I think some of you guys are computer people, so you kind of understand the importance of that. But I only had like two people say that they were good, or no, Colton came through. I only had three people say they're good. So do I have everybody now? Let me do one more test just to make sure you hear me. Always make sure you fast forward. You shoot me another "I'm good" or "I'm fine" or "I'm here" or smiley face, something like that, just to make sure we're all in this. Thank you, Morgan. I see Morgan. Thank you, Alex. Thank you, Katie. Thank you, Ian. Thank you, Colton and Carter. Timmy, thank you. Hey, Caitlin. So, are you guys like, are you working like the to go thing through Olive Garden? Are you getting a lot of hours through that, or what's that look like? Oh, that's right. I got you. So, like, you're not working at all? Oh, okay. I'm with you. Makes sense. I think Timmy and OSU, they may be looking for some people on the farm. So, Katie, you may go out there and help Timmy. So, all right. Jumping back into here to number 5. A small television company estimates that the cost in dollars. Hey, hold on. This is actually an important thing. That was my dog that just growled. That wasn't me. Easy, Rocket. But Kurt, so did they close it down? Yeah, me too, Morgan. Did they shut AMC down, or I thought it was just like half of it? Cool beans. All right. Sorry about that. I can be distracted easily. You all know that. So, a small television company estimates that the cost in dollars of producing X units of a new model TV is given by C of X is that. Find the production level that minimizes the average cost per unit. Complete the chart and explain why the average cost to produce TVs is so great for either small or large number of units. All right. So, here's the thing. So, what we look at is the cost. We're looking for the cost here. So if I make 10 units, so here's our cost function. So we're going to plug 10 into the x's here. And then when you plug 10 into that, you get this 80,420. Which, if you divide the cost divided by how many units you just made, it would come out to be $8,420 would be your average cost to make one of the units. If you do 100 TVs, if you plug 100 into here, you would simply get 86,000 even. And of course, that would lead you to about $860 per unit. If you do 1,000 units, that's 320,000, which comes to an average cost of about $320. 2,000 would be $960,000, which is about $480. And if you did 5,000 units, that would cost you, by plugging 5,000 into X, that would cost you 5,280,000, which would give you a unit price or a per TV price of $1,056. All right. So, sorry about that. So, really, what we're looking for here is basically find the production level that minimizes the average cost per unit. So, if we're dealing with average here, the average cost per unit, really, we're going to use our function 8,000 or 80,000, excuse me, 80,000 plus 40x plus 0.2x squared. And we're going to divide it all by x. So that's how much, this is the cost function. And since we're finding mean, the total cost divided by how many we're making will give us what we need. We can rewrite that to kind of make our derivative a little bit easier because we have one variable, one byte. Everybody knows the rules. So it looked like this, 80,000 over x plus 40 plus 0.2x. And that's just dropping an x under every thing up here and then simplifying it. So then from there, we set this equal to 0. And as we've seen, when a number's up here and you just have an x on the bottom, it's negative 80,000 over x squared plus 0.2. I then subtract the 0.2 from both sides. That's going to make everything even. Or not even, positive. Then multiply both sides by x squared. 0.2x squared equals 80,000. Divide both sides by 0.2. We get x squared is equal to 400,000. And the square root of 400,000 would be x equals $632.45 40 or not dollars, excuse me. These we're talking about units here, the number of units we have over here. And this amount of units would be what would minimize the average cost. And then the average cost, if you were to plug this back into x, you're going to get an average cost of $293. Okay. And then it says, explain why the average cost to produce TVs is so great for either small or large number of units. So obviously, if you produce 5,000 units, the price is up there. If you produce just 10 units, that price is really up there. Can someone just, I'm sorry, Katie. Can someone maybe type in the chat box just a quick explanation on why you think that is? Explaining that. Okay, Alex said they are most likely made on an assembly line, and companies usually buy resources in bulk, not in small numbers, and they get deals when they buy in bulk. I agree with that. Alex, what would be your reason why it's a trouble to make a large quantity amount? And Colton says the human typewriter. Do you want to give some explanation to yours, Colton? Or are we just assuming everyone knows what you're talking about? I don't know if y'all discussed that in a class or what. Give you a few seconds to respond. Oh, okay. I got you. I thought that I didn't know if you were like with a human typewriter, if you were like applying some kind of like that it's slower, it takes more people. I didn't know where that was going, but yeah, Timmy, the reason we can't have a large quantity, because it would either A, cause us to hire more people, or B, we'd have to buy more machines, or as you just said, Alex, we'd have to buy more resources, get more resources. So we always say, like in baseball, there's a sweet spot to the bat, and if you find that sweet spot, you're in good shape. And same thing with business. There's a sweet spot, not too many, not too less, but there's a sweet spot where we can work efficiently in business. All right, last three problems. All right, no worries, Katie. Okay. A TV cable is to be laid from the cable company to an island 7 miles offshore. So, boom, cable company 7 miles offshore at a cost of $20,000 per mile along the shoreline and $50,000 per mile underwater. How should the cable be laid at the least expensive cost if the distance along the shoreline is 12 miles, as shown in the figure to the right? What is that cost? What is the most expensive way to lay the cable? Complete the chart. So I think that, again, you're always going to hear me say that the table is pretty, in my opinion, it's very helpful. So what if X is 0 here? Okay, so what if there was no distance what if they didn't go hit this shortcut right here and they just said, you know what, X is 0, so we're going to scale this all the way back here. What would my water cost be? Well, that means that I'm going 7 miles underwater with this cable. If X is 0, I'm going 7 miles underwater. 7 times 50,000 would be 350,000. And I would go 12 miles on shore, which is 20,000 per mile. So that would be 240,000. My total cost would be, if I then put those together, would obviously be 590,000. Then what if X is 6? So what if that was 6? So think in the terms of Pythagorean Theorem. So if that was 6 here, then, so if that was 6, 6 squared is 36, 7 is 49. 49 plus 36 is 85. So then this distance would be radical 85. And then if you said radical 85 times my water cost, which is 50,000, so square root of 85 times 50,000, that would give me 46,000, or excuse me, 460,977. So then if I took 6, all right, so that's the water cost, just using Pythagorean theorem to find that distance here. Then if I took 6 miles off of that gives me 6 miles of land or shoreline, right on the on land, which is 20,000. So 6 times the 20,000 would be 120,000. And then those two numbers combined would be 580,977. Okay. But now what if x was 12? So what if x was 12? So it'd almost be like we're running it the whole way, right? So if x was 12, so way out here, this distance was 12, then that would mean it's underwater the whole time. So if x is 12 and that is 7, that would be 144, because again, think about that triangle, 12 a squared plus b squared. 144 plus 49 would be 193. And then we multiply that times our underwater costs, which is 50,000. And we get the number 694,622. And that's just making a right triangle. That's 12. This would be 12. That would be 7. And the length here would be radical 193. I say radical 193 times the 50,000 underwater. That leads me to this number right here. There is no land cost because I didn't go land. It's total underwater the whole time. So therefore, my total cost there would be 692. Okay, so here's what the table, and that's what the table gave us here. But in the other problems, it gives us like what's x, and what are you doing to find this. So you just got to think about this. My total cost C. So my total cost C is going to be that 50,000 times, and again, really what I'm asking myself here is how did I get the water cost? Okay, if I'm thinking more on the lines of water cost, it's the water cost plus the land cost is my total cost. So it's 50,000, and then really x is all about what's happening under here. So it's the square root of x squared plus 49. If you think about how we found 6, how we found that, we said 6, when x is 6, 6 squared plus 49, and then we did the square root of the addition of that, the square root, and got 85. So that's what we're basically doing here to find that. This right here would be the water cost. Then we add that with our land cost. And then the land cost is 20,000 times, and it's just 12 minus whatever x is. Okay. And that gives me that right there, which is pretty nasty. But here's what I can do to kind of make this a little bit easier. Because when I'm going to take the derivative of this right here, when I take this derivative of all this, I think it would be much easier if I go ahead and knock these zeros off here. And what you need to think about is I just basically moved the number 4 decimal places. So that will save me a lot of time and I can do that because they both have 4 zeros on them. But when I type this back, once I get this number X and I type this back in to see my total cost, I would either have to use 50,000 and 20,000 or whatever number I get from here, I'd have to move the decimal 4 times to the right. Okay. So actually, and that's just like a little algebra trick that could help. So C is actually 5 times the radical X squared plus 49 plus 2 times 12 minus X. Now let's derive from there. Can't combine anything else, can't really do anything else, so we can derive from here. So the way I would think about this is I would think about moving this 5 out. Due to like our time, I don't want to take forever. That would be how I would work that derivative right there. I'd move the 5 out and write that to the 1/2 power. And again, just keep that 5 out of there. Because it's just going to give you a decimal, which could, which doesn't make sense to use right here. And then bring this 1/2 down, keep the inside times the derivative of the inside, which is 2x. My 2's cancel. I'm left with 5x on top, and then just push this down to the bottom. Radical x squared plus 49. Okay. So then from there, again, I'm going to write this out for you right here. So that's going to be 5x over radical x squared plus 49. And then think about if I distributed that 2, that'd be 24 minus 2x, so it should just be minus 2. Okay. Now, from here, I'm going to add 2 to both sides. And I'm going to do so add 2 to this side, right? And then I have 2 equals all this. And then I know I'm going to multiply this to get that denominator out. So I should have 2 radical x squared plus 49 is equal to 5x. So I just skipped like 1 or 2 steps there. I added 2, and then I multiplied both sides by radical x squared plus 49. From here, I need to get rid of this square root here. So let's just square everything. That would leave me, put this square on the 2. That would be 4 times x squared plus 49 equals 25x squared. Then from there, distribute, you get 4x squared 4 times 49 is 196 is equal to 25x squared. If I subtract 4 on both sides, it cancels there, leading me to, I'm going to switch sides here, 21x squared equals 196. Divide both sides by 21. I get x squared is equal to 9 1/3. I do the square root of both sides. I get x is equal to, that would be about 3.055 miles. And that should make some sense because the square root of 9 is 3, so just a little bit past 9. So my minimum cost, it says what is the cost? So the cost, if x is 3.055, sorry, I didn't mean to take that out of the picture. So if x is 3.055, I would literally just plug that back in there. But keep in mind, if I do it with the one without the zeros, I'm going to have to move the decimal place. But you're going to get the value of 560,789. And then it also asks, what is the maximum expense? What's the most expensive? And again, if you think about what would be the most expensive, it would be to not use the 20,000 at all and just use 50,000 the whole time. So then my max cost would be whatever it was underwater, 694,622, and I'm just pulling that from right there, guys. I know you can't see that. I'm just pulling it from the total cost of the underwater one. And of course, that would be all underwater. Questions? Thumbs up. Something. Give me something. Morgan, what's that yelp mean? Like, this is stupid? Or like, yep, I'm good. Okay. Sorry that you are bored, Caitlin. We are getting there. That's exactly right, Timmy. So, just wait till you get to college classes, Driftmeyer. I guess that's the only thing I can say now. I used to have to sit in my master's. I sat and listened to someone talk for 3 hours over education, not doing problems, and I'm not working along. I'm just listening. And it was the most boring thing ever. He wasn't that influential, so it's kind of hard. Yeah, jokes are hard, Timmy. Jokes are hard because you guys would just, yeah, right. I'm with you on that, Katie. But jokes are hard just because if I say a joke, then you guys are just going to literally flame me in the group chat and be like, listen to this idiot. So, all right. But if you want some jokes, I can drop some jokes. A rectangular area is to be fenced in using 2 types of fences. The front and back uses fencing costing $5 a foot, while the side uses fences costs $4 a foot. If the area of the rectangle must contain 500 feet squared, what should the dimensions of the rectangle in order to keep the cost a minimum? Okay. So here's what we're thinking of. We have a rectangle. Rectangle. We know that the front and the back, which would be X, are using $5 fencing. And the sides, Y, is using $4. So I need to find a total cost, a primary equation that would give me my total cost no matter what X and Y is. Somebody type that into the chat box. The equation right here that I use for my total cost. Awkward silence. There we go. Okay, cool. Yeah, there we go. All right. So yeah, those are all all three of you guys, right? Good. Colton, Morgan, Alex, Carter, if you're in on that mix as well. So if 5, I would say here 5 times 2 of the x's, 5 times 2x plus, and there's 2 y's, so 4 times 2y, which would then lead us to what everyone sent, 10x plus 8y. Very good. The issue with that is that I have 2 variables. So now let's come over here and say, all right, where was there a restraint at in this problem? Where was there a constraint that we have to meet that as well? And that's that the area x times y has to be equal to 500. Good, Timmy. So y is 500 over x. We plug that back in, we get C is equal to 10x plus 8 times 500 would be 4,000 over x. From here, I can derive it. So we're looking at 0 is equal to 10. And again, x on the bottom, that there, think about that being 4,000 x to the negative 1 power. So that would just be negative 4,000. And then don't forget low over x squared. From there, I'm going to subtract 10, which is going to, and then I'm going to have a negative on that side and this negative. So I can really just say 10. And then I'm going to multiply both sides by x squared. So 10x squared is equal to 4,000. X squared is equal to 400. And as Timmy said, x is equal to 20. I then get my total cost by plugging 20 back into this total cost formula right here. So that's 200. 20 times 10 is 200 plus 8 times, or excuse me, I actually said that backwards. Or did I say it backwards? Okay. Oh, yeah. There we go. So X actually represents what I need here, right? So my front and back front and back, I need, if X is 20, I'm going to need 20 feet there. So 10 and 10 there, so 20. And then the sides is 25, taking me to a total cost of 400. I get 25 because when I plug 20 into that X, 500 divided by 20 will give me 25. And then when I plug these numbers back in, that will give me the total cost of 400. Okay? So, next problem B. If the builder has only $800 to spend, what is the largest area that can be fenced in? So, again, we're looking for the largest area. So now my primary is area is equal to X times Y. And I have two variables there. So that means I have to have a secondary equation. And most likely that secondary equation is has some kind of restriction. And my restriction right here is my total cost is $800. I would take this approach more myself because I'm more about the budget than I am about, how much space I need in terms of that. So I like this approach better of, hey, I have this much money. What's the largest area I can make with this much money? So 10x plus 8y, that's the cost function, is then equal to 800. So I'm trying to find my largest possible area, and this right here represents the cost equaling, I can only spend 800. So 2 will go into all that. So I could break that down to 5x, and I'm just trying to make it easier for the derivative. So simplify all that by 2, and that takes us to this 400. And then y is then equal to 400 minus 5x over 4. And I can simplify this 404 as long as I put the 4 with the negative 5x as well. So that's y equals 100. 400 divided by 4 is 100 minus 5 force x. So now I plug that back in, and I get area is equal to x times 100 minus 5 force x. I then distribute this and get A is equal to 100x minus 5 force x squared. I then take the derivative of all this by setting it equal to 0, trying to find the maximum here. 0 is equal to 100. And then if I go and do this to the side, if I go and calculate negative 5 force x squared, and that x squared is not with the denominator, it's just kind of out to the side. And I go and I multiply all that through, I'm going to get negative 5 over 2x. And that should make some sense because if you multiply 2 times 5, you get negative 10. And then negative 10 over 4 would be simplified to 5 halves. We then Subtract that 100 to both sides. That equals 5/2 x. Multiply 2 on both sides. 200 equals 5x. X then equals 4. 40. So x equals 40. And then if we plug 40 back in to our x over here, we should get y to be 50. And this is all feet. And then my total area would then be 2,000 feet squared. Good, Alex. Okay, last problem of the day. The cost of fuel, and you guys can always go back and rewatch this, pause it at any time. The cost of fuel to propel a ferry boat through the water in dollars per hour is given by this function, where V is the speed of the boat in miles per hour. In addition, the cost of labor and maintenance to run the ferry is $2,000 per hour. At what speed should the ferry travel to minimize the cost per mile traveled? Okay, so again, what most of these economic ones are looking for is cost. We're trying to maximize, we're trying to minimize something. So the cost is, what we're dealing with here is F is a function, F of V. But not just the function gives its how much it costs. That's the cost to fuel it. But in addition to the cost, it's also $2,000. So F of V plus 2,000 would represent what we're dealing with here. And that's dollars per hour. Okay, so I can rewrite that as like C equals F of V is V cubed over 8 plus 2,000. And again, that's how much it is dollars per hour. So it's just, again, my cost is the function cost plus the 2,000. Okay, so, and if you remember back on the television set one, on that television set, when we're trying to find the production level that minimizes this, if you recall, we took the cost factor and divided it by the unit X of the number of units we're dealing with here. So we're going to do the same thing here, but we're going to do it with speed. And it says V is speed. Sorry about that. So V is speed. Let me get to where you can see it. So V is speed, so it should look something like this. We can just call this mean, or M of V is equal to this right here, the cost function, plus 2,000 all over V. And V represented in miles per hour. So our cost divided by the speed. And we're looking for that V. So Alex said, would we not multiply 2,000 by the number of hours? We actually don't know the number of hours. And we're just looking for the speed. Okay. So what this would be equal to, but Alex, I'm not saying you're wrong because again, you're the human calculator. So I'm sure if you do it the way you want to do, and then I do it this way, I'm sure we can probably come to the same conclusion. So not saying you're wrong, but I don't know if I'm following your question very well. So if I say v cubed over 8 divided by v, that's going to take me to v squared over 8. And that's just keep, change, flip with that. So keep this one, change it to multiplication, and then flip this to 1 over v, and then you could cross simplify. And then plus 2000 v, or 2000 over v, sorry. And then from there, we just got v squared over 8 plus 2000 over v. We're going to set that equal to 0, and we're going to derive it. That would take us, if you take that to the side and do the derivative low d high minus high d low over low low, that's going to take you to v over 4 once you simplify it out. And of course, that would take you to minus 2000 over v squared. If I then add this to both sides, v over 4 is equal to 2000 over v squared. And I cross multiply these, I get v cubed is equal to 8,000. And the cube root of 8,000 is actually a whole number, to be 20 miles per hour. So if they keep that boat at 20 miles per hour, that will minimize the cost. And guys, other than that, that's it for today. If you go back and you're looking at your schedule for this week, so today we covered 22 homework. We completed 23 notes. Tomorrow, knock out 23 homework. And then Friday, we'll cover 23 homework. And then I also want you to start the 23 take-home test. And I may give you like a hint or something for that take-home test, if you're here on the live session, if you're able to make it. If not, obviously go back and listen to the recorded. Any questions of me? Again, this is a very complicated process, and I don't know if this is the best route, but I don't know any other route. I was actually just going to have you guys to like meet me at the Grove City Library to kind of meet and just to kind of work through all this together and that. But then they told us we could not meet with a small group of students. So that was kind of my plan, was just to say, hey, meet me at the library at, I don't know, 1 o'clock or something, and we'd work through it, just because this is pretty challenging. But here's the issue. Yeah, and I know other people are using Zoom, but the difference in Zoom is, one, I don't mind. I actually have the Zoom account or whatever because they had everybody get it, and I don't mind to meet with you if you want to discuss stuff one-on-one. But about like, hey, I don't get why this is doing that. But to me, it's again, seeing your faces, to me, I don't know how they're doing it. I don't know if they're working out problems like this or what. But to me, YouTube is just an easier process in it all. Not saying it's the best way though. If you all don't have anything else, I'm good. You can go ahead and fall out. I'll see you here. What is the schedule? Schedule is 1 o'clock on Friday. It may not always be the same time, but it should be around the same time, guys. So. If you have questions, feel free to hang around. I'll shut the live stream down here in a second. But if you have questions, feel free to ask me. You have a question, Colton? See you, Alex. Good work today. Is that a question, Colton, or I can't tell what that is. I'm sorry. Oh, good day. Good day, sir.